Hello everyone. So today we will study about benzoin condensation and Perkin condensation or Perkin reaction. So let's start. So first we will see what is benzoin condensation. So benzoin condensation is nothing but the condensation between or the condensation reaction between two kinds of or two aromatic aldehydes, especially benzaldehyde, in the presence of some catalyst. For example, you have here we use KCl. In presence of KCl in water and ethanol, it will form alpha hydroxy ketone. So it is the benzoin. Okay. Why it is alpha hydroxy ketone? See, this one is ketone group. Okay, C double bond O. So this carbon, next carbon is alpha carbon. So in alpha position, one hydroxy group is there. That's why the product is called alpha hydroxy ketone. So this is benzoin. So this is the overall benzoin condensation reaction. So next we will see the mechanism. So in mechanism we will see how the reaction proceeds or it's complete. Okay, accomplished. Addition of the cyanide ion to create a cyanohydride affects an unpolling of the normal carbonyl charge affinity and the electrophilic aldehyde carbon becomes nucleophilic after deprotonation. So this is our one molecule of aromatic aldehyde and this one is carbonyl carbon C double bond O. Okay, so we know in normal carbonyl carbon is delta positive and oxygen is delta partial positive. A negative charge will be there. Why? Because we know oxygen is electronegative atom than the carbon. That's why there is pulling of electrons towards itself and thus the oxygen will be partial negative and carbon will be partial positive. So this cyanide ion, what it will do? It will do a unpolling effect. So what is unpolling effect? Unpolling effect is nothing but the uh, alternation or change of charge. Okay, so it will give this molecules. So see, cyanide is attacking this one. So and this pi double bonded pi electron will be taken up by the oxygen. So it will having negative charge. Okay, one negative charge here. So next, in presence of water, the water molecule will give one H plus from H2O. So it will form this one. OH, O is there. So H from water. So it is giving this one is making OH. Okay. So this compound is known as cyanohydrin. Okay. Cyano group is there and hydroxyl group is there. So this is called as cyanohydrin group. Okay. So next, a strong base is now able to deprotonate at the former carbonyl carbon atom. So a strong base OH, okay. So or simply OH will take up this hydrogen, okay. So if OH take up this hydrogen H plus or proton, this will make this carbon C negative. So earlier the carbon was positive, okay, but here it is negative due to the presence of cyanide. Okay, so this is called the unpolling effect. Okay, and ultimately this is the bond share or electron sharing between the aromatic group of the aromatic aldehyde. Okay, so ultimately this molecule will be used in the next step. Okay, so next step we'll see a second equivalence. So we know in the reaction, if we from the previous slide, then two aromatic aldehyde is are used. Okay, so another second equivalent of aldehyde reacts with this carbanion. So this is carbanion C with negative charge A second equivalent of aldehyde reacts with this carbon ion, so another aldehyde, aromatic aldehyde, would react with this carbon ion, and elimination of the catalyst regenerates the carbonyl compound at the end of the reaction. So at the end of the reaction, catalyst will be regenerated and we will get the product. So how we will get the product, we will see. So this carbonyl carbon will attack by this electron pair or this carbon or carbon ion, so it will form this one. Okay, so this negative charge will attack this partial positive carbon, and this electron, double bond electron, will be taken up by this oxygen. So ultimately we will get here one negative charge. Next, one water molecule will attack. It will give its give its proton or H plus to this oxygen, so we'll get this product. Okay, so this is the product. So next, what will happen, another base or OH will take up this hydrogen. Okay, this hydrogen from here, so oxygen will attain a negative charge. So next, what will happen, this negative charge or this electron pair will be shared between this carbon and oxygen, and Cn will be eliminated out. This is our catalyst. So we know at the end of the reaction, catalyst always will be regenerated. So ultimately here C double bond O will be formed, and this is our ultimate product, alpha hydroxy ketone or benzoin. So I hope you understood you have understood this benzoin condensation. It's very simple. Okay. So next we'll see application of this benzoin condensation. So benzoin condensation reaction is useful in various organic synthesis and reactions. So this is the one application. Anisaldehyde and para-tolualdehyde give the corresponding alpha hydroxy ketone, and perfurel gives furoin. Okay, so this is one or two example. Benzoin condensation also useful in polymer chemistry. So it is also used in the polymer chemistry for production of polymer as well as condensation of new monomers. So these are the applications of benzoin condensation. So next we will see Perkin reaction or Perkin condensation. So it is devised out by the scientist William Henry Perkin. Okay. So we'll see what is Perkin reaction. So in this reaction, we'll convert an aromatic aldehyde. So this is benzaldehyde is aromatic aldehyde. Why it is aromatic aldehyde? Aromatic group is there and aldehyde group is there. Okay, CHO is aldehyde. So aromatic aldehyde and an anhydride. So this is acetic anhydride. So we'll convert this to an alpha beta unsaturated carboxylic acid. So this is alpha beta unsaturated carboxylic acid. Why it is alpha beta unsaturated carboxylic acid? Because in this is C double bond OH group. Okay, so this carboxylic acid group, so first carbon, so from carboxylic acid group, first carbon is alpha, this is beta. So in alpha and beta position there is one unsaturation, and this is aromatic acid overall. Okay, so that's why it is called to an alpha beta carboxylic acid or aromatic acid using sodium acetate or acid of salt of that acid. Okay, corresponding acid. So and a base. Okay, the regiochemistry of the reaction, the relative position of the carboxylic acid and aromatic ring in the final product can be either E or J. So regiochemistry means there is one unique direction, not unique, there will be changing of the bonding bonding or special orientation of the molecule will be changed, and ultimately will get either E or Z. Okay, that means the product which we will get, there will be, during the mechanism we will see there will be rotation of the or changing of the position of the various group, and ultimately we may get either E or Z product. Okay, so the mechanism goes through numerous steps including several addition and elimination. So if you see the mechanism next in the next slide, we will see the various steps are there, okay, or numerous steps are there, but there is nothing special there, only addition and elimination is occurring, okay. So we'll see. So this is the reaction benzaldehyde, that is our aromatic aldehyde in presence of an anhydride, that is acetic anhydride, and our sodium acetate, okay, or sodium salt or any salt of acid, and which will convert our aromatic aldehyde and anhydride to alpha beta unsaturated carboxylic acid. So this reaction and this reaction is same, okay. Don't be confused. This is benzaldehyde, this is also benzaldehyde, this benzaldehyde group, this aromatic group, that's why I put AR, okay. AC2O, that is, this is acyl group, okay, CH3CO. So the whole 2 is AC2, okay. So O, then CH3CO means ACO, okay, that is sodium acetate. So in between we are getting this one, and ultimately we will get the product as cinnamic acid, which is alpha beta unsaturated carboxylic acid, okay. So let's see the mechanism. So this is the main reaction again I have shown. So from that one I'll show the mechanism. So see, first what will happen, this is acetic anhydride group, okay. This is CH3, C double bond O, O, C double bond O, then CH3 again, okay. This is CH2 and H. So this acyl group will take up the H from this acetic anhydride, okay. So where from we will get the ACO group? From this one, okay. So it will take up the H from here, so electron will be shared to this one, so ultimately we will get the enolate, okay. So and this oxygen double bonded this double bonded electron will be taken up by the oxygen. So see the reaction, this CH bond will go here, bonding electron will go here, and ultimately form double bond, okay. C double C double bond CH2, and this C double bond O, the double bonded electron will be taken up by the oxygen, it will form O negative, okay, oxygen negative, okay, or alkoxide ion. Next what will happen, this double bond will shift attack here, and this oxygen will shift here to regenerate C double bond O bond. Okay, just see AR or AR, then this double bond electron is coming here, so we are getting this one O negative. Okay, then our, okay, this one is this position is this, and next our C double bond O, C double bond O, 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 then C double bond O, C double bond O, CH3. So this is the product. Next what is happening? Intramolecular acyl transfer. So this acyl group will come up in this position. Okay. So this is intramolecular. Within the molecule, the acyl group CH3CO group will be transferred from this position to this position. To occur this, what will happen? First, this electron will be bonding one bond here, this electron will be taken up by this oxygen, so ultimately we are getting a cyclic in between intermediate product. Next what will happen, this oxygen electron will come here, and this one will come here, okay. So this bond will be broken, so ultimately this acyl group CH3CO group is coming here, okay. So next what will happen, acyl transfer will be there again, one molecule of this one acetic anhydride will come, and this acyl group will be transferred from this acetic anhydride group to here, okay, in this position. So this is acyl transfer. Next what will happen, E2 elimination will occur. So in E2 elimination what will happen, this bond is breaking down. Okay, OH will come, it will take the H, and this bond will break. O will CH3 C double bond, O negative will be generated. So ultimately here AR C, then there will be double bond. So this is the double bond generated by elimination reaction or E2 mechanism. Okay. So next, what is happening? One ACOH will be eliminated out. So how it will eliminate? This will this bond electron will be taken up by this oxygen. OH will attach here. So ultimately we are getting this one. Okay. Next, what will happen? This O will donate this electron pair to bond form here. Okay, and this O, the C O bond will be broken down. Okay, so ultimately what will be generated? This AR CH double bond CH C double bond O, then O negative. So we are getting this product. Okay, and lastly ACOH, that is acetic acid, will come, then it will give its proton or hydrogen to this oxygen, okay, to ultimately generate CH3 C double bond O. That is our that initial part catalyst. So ultimately we will get ACO. Okay, the catalyst will be regenerated and we will get our product. What is the name of this product? Alpha beta unsaturated carboxylic acid or cinnamic acid. Okay, so this is the mechanism. I hope you have understood. So next, applications. So applications of Perkin reaction are to prepare the cinnamic acid, that is alpha beta unsaturated carboxylic acid. I hope you have understood. So thank you.